In section 1.4, we'll be measuring some angles and classifying them, naming them, just a lot of basic things that go with the geometry concept of an angle, which is made by two rays. Remember, rays shout out from one point, so this would be called ray, and it depends on this first point, WP. Well, to make an angle, I have to shout out from that same initial point and make another ray. And these two rays are called the sides of the angle. And angles are measured in degrees, and a degree is a very small unit of measure. Like there's 12 inches in a foot. To go around a circle, there's 360 degrees. It's a very tiny unit of measure. So it's as if you were to chop that up into 360 little pieces. So there's a sketch of our angle. So we just said that the sides of the angle are those two rays that both shout out from the same vertex. So the sides of this angle would be ray AB and ray AC. The vertex is this shout out point, A. And we can name this one four ways. Because there's a number in here, we can call it angle 1. We need this symbol in front of it to get full credit. So there's going to be a lot of notation in geometry. And it really matters. Because without that angle in front of it, it's just the number 1. It's a count. All right, so the other way we can name it, because there's only one angle there at that vertex A, we actually can call it angle A. These are the least common ways to name it right here. Normally when we name angles most of the year, we're going to say angle. And what we do is we put the vertex in the middle and then we hug it with the other two endpoints. So we can put the vertex in the middle and then hug it with the other two endpoints. These are the ways you'll see it most often. So, having said that, you should pause the video and go ahead and try this one. It says, what are two other names for angle 1? I can call it angle, and the vertex goes in the middle, and the sides hug it, or vertex in the middle, and the other endpoints that hug it. That would name angle 1. I cannot call this one angle M, because if I were to ask somebody to come up here and measure angle M, they wouldn't know. M is the vertex of three angles actually. It's the vertex of angle 1, the vertex of angle 2, and the vertex of this big one. So we would have some further questions. It's only when there's no other angle there that we can call this angle P, because it's very clear if I say measure angle P, you know exactly to measure that one. So the next question says, what are two other names for angle LMK? Well, angle 2, right? LMK is this one, or I can reverse that order and say KML. Don't forget that angle symbol in front of it. So the classifying you've done in middle school, so I'm going to go through it kind of quickly. But right angles are always exactly 90 degrees. An indicator for that is this box. If you do not see the box, or it doesn't say it's 90 degrees, you do not assume that it is just because it looks like it is. Because in reality, it could be 89.8 degrees. So you need to see the little box, or it needs to be told that it's a right angle. Then you know it's exactly 90. The acute angle is when we squeeze it shut and make it less than 90 degrees. If I were to estimate this one, I'd say it's a little past halfway. Maybe this one's about 50 degrees, and it's an acute angle. When we crack it open wider than 90 degrees, we have, I'm going to make a greater than symbol, we have an obtuse angle. So I guess if this were 90 and cracked open, maybe I would say maybe that's about 110 degrees. I'm just guesstimating. And our fourth classification is the straight angle. Straight angles look like lines. They look like a pair of opposite rays from last section, and their measure is always 180. So we have 90 180 less than 90, greater than 90, and that's called their classifications. So if you're asked to classify, those are the words we're looking for. So now we're going to do two things. We're going to measure and we're going to classify each angle. So two answers. Be careful with that and, because a lot of times on tests and quizzes, students just measure and they don't classify, or they don't know what this word means. So I'm telling you, that word means you're going to call it an acute, obtuse, a right, or a straight angle. So let's go follow the directions here. I have to travel from L, where's L? Here it is in blue, I'm putting a dot on it, into K for the vertex, and then out to N. I can see that that's cracked open wider than 90 degrees, so its classification would be obtuse. Its measure is greater than 90 degrees, so when I see this going right through here, I'm like, ooh, that's between 30 and 40. Don't say 35 degrees, because we read the numbers that are greater than 90. So we would say 145 degrees. Make sure these answers match. If you see obtuse, your measurement better be more than 90. Next one, I'm supposed to go from L, again into the vertex K, and then out to H. Well, now I have an acute angle. This is cracked open less than 90 degrees. So again, when I see these two numbers that this ray, is going through, I choose the one less than 90 degrees, which would be 35. It's right between 30 and 40. Up next, we have J. So in blue, purple, let's say, I'm going to hop on to J. I'm going to head into K and out to L. All right. Now, that's acute. I can see it. It's less than 90. So the classifications are easy. Now, there's two ways for you to get the measurement for that angle right there. So I'm going to go in purple. You can just notice that this is going by tens and go 10, 20, 30, 40, 50, and then half of one, 5, and say it's 55 degrees. If you want to be more mathematical about it, you can just do the difference between 90 and 35, because it's between 90 and 35. And you'd still get that 55, so that's just a matter of preference. Do you want to count the spaces, or do you want to subtract the two numbers? Either way, they're going to match up, so I really don't care. I'll never know how you found the measurement. All right. Let's go look at H to K to N. H into K, straight across or opposite to N. Well, that's our straight angle. A pair of opposite rays make it, and it always measures 180 degrees. So I think we're good with that. We probably don't need any more practice, right? I mean, it's a pretty easy concept. So congruent means we have the same measure. Loosely, it sort of means things are equal, but there is a difference that I'll be explaining in a little bit down here. But in your mind, you can think if two angles are congruent, their measures are equal. If two segments are congruent, their measures are equal. Okay, so same measure. Remember, the symbol for that is an equals with a little squiggle on top of it. We talked about that when we were talking about congruent segments. So angles are congruent on here due to the fact that you see in purple, this single arc here and this single arc here. So there's two ways you're going to know if angles are congruent. You're either going to see their measures, like if this is 40 and this is 40, I know they're congruent. Or in the absence of the measurements, you just see those single arcs, you know they're congruent. The minute you see a double and a single, it means even if they look the same, they're not. So the angles are congruent due to the single arcs that I see in there. So we would say angle A, vertex in the middle, B, C, is congruent to angle Z, vertex in the middle, X. Z, Y, X. What that means is their measures are equal. So if we want to kind of turn that into measurements being equal, we'd say the measure, the little m means measure of angle A, B, C is equal to the measure of angle Z, Y, x. So they're very, very similar. If the angles are congruent, their measures are equal. If the measures are equal, the angles are congruent. Very, very, very similar. Next up, we're going to talk about the angle addition postulate. We already dealt with the segment addition postulate in another lesson that said when a segment is chopped up into pieces, the two pieces add up to the whole way across. It makes a lot of sense, correct? Well, for the angle addition postulate, it says if an angle, this big one, is chopped into two angles, then the two pieces add up to the whole way across. Okay, now there's a little bit of notational mishap here. There should be little M's in front of these. Okay, so I'm going to put that on there. But basically, it just says that the two pieces add up to the whole way across. So let's go use a little algebra with that. Because of their numbers, obviously, it's kind of easy. You just add them up, right? But let's throw some algebra in the mix here. So if measure of R to Q to T, we'll have to figure out which one that is. So I'm going to start at R, head into Q, go out to T. I'm like, ooh, that's the whole measurement of the whole big obtuse angle. They want me to find the measures of the other angles. Well, I'm going to use my angle addition postulate. The measure of one of the pieces, this one, plus the measure of the other piece, this one, has to add up to the whole way across, which I was given as 155. And then we pass the ball to algebra and have at it. So we'll combine those like terms. 7x's. Down 20, but gain 14, we're down 6. We're going to add that 6 to both sides because we are on the x attack. So we want to get rid of that subtract 6. This makes 0, right? So now I have 7x equals 161. And this is 7 times x. So I divide both sides by 7, and I'll get 23. Be careful, because if you're doing a delta math assignment and you were to enter 23, it's going to give you that red X, because that's not what it asks me for. It asks me for the measures of these other two angles. So my 23 has to go in and replace that X. So I do 4 times 23, which is 92, right? Minus 20, which would be 72 for RQS, 72 degrees. On the other one, I have to do 3. Let's do it up here. 3 times 23, which is 69, plus 14. Okay, and I don't have a calculator on me, so I'm going to do this the long way. That's 83. Now, how do I know that I did it right? Well, if I add these on my calculator, guess what I get? Bam! The whole way across. All right, so if I were you, I would pause this video, because if you were absent in class, that's what I said. All right, I'm going to have you go give yourself a little self-quiz, okay? So pause the video, go do the next problems, and then come back and correct it. Name this angle 3 ways. So this would be worth 3 points. See how you did. I can call it angle, have to have the G in the middle, F on one side, H on the other. Have to have that vertex in the middle, but I can swap the two. Don't forget the angle sign in front of it. If you did, only give yourself 2 points. And then I can also call it angle G. So give yourself 3 if you had all 3 of those. If you forgot the angle symbol, give yourself 2. Classify it. Remember, that's one of 4 words. Right, straight, or acute obtuse. And this is correct open wider than a 90, so that would be obtuse. If you wrote that, give yourself 1 point. If you don't know what classify means, maybe star that. Remember to get that on your note card, because on a test, if you come up to my desk and say, I don't know what it means to classify it, I'll say, well, I can't help you. Okay? This says find the measure and classify. All right? So it's 2 things. So we're going to go 2 points, 2 points, 2 points on each of these. BFE. B into F, out to E. Well, let's classify it first. That's obtuse, so give yourself a +1 if you wrote that. So then I need to pick the measure greater than 90. So I got to erase that a little bit. Looks like it says 130. So 130 degrees and obtuse. The next one in blue, BFC. Let's do that. B into F into C. Well, that's a cute little angle, right? Cute. Now, I can either count the tick marks from C to B or B to C. Doesn't really matter. Or I can subtract 75, which is where this one's hitting, right between 70 and 80, minus 50, which I think I'll choose to do. That's a 25-degree acute angle. And EFA is that straight angle, and it measures 180 degrees. So 6 more points for that. Next up, it says JKL is a right angle. So I know that this whole angle is 90 degrees. What else do I need to do? I need to figure out what X is. Because it's asking me for LKM, that means I'm going to need to figure out what X is to plug it in. Well, our angle addition postulate says that when a big angle is chopped into 2 smaller angles, the 2 smaller angles have to add up to the measure of the whole thing. Well, it's a right angle, so it's 90 degrees. So give yourself a point if you did that. Combine like terms for 18x, and then the 3's cancel. That's nice, so give yourself a point if you did that. Divide both sides by 18, and I don't need you to show that step, but final answer of 5. But I'm not done, right? Because, and these are the point values, 5's got to go in here. So if you forgot to plug that in, beware. I'd have 30 minus 3 is 27 degrees for my final answer. So on your little self-quiz, let's see how many points we had. We have 4 for this one. 4, 5, 6, 7, 8, 9, 10. And then let's go back a page. 10, 11, 12, 13, 14. So it looks like we have 14 points. All right? For a little fake formative quiz. Have a good one, guys, and we will catch you later.